example here will probably be new material. And this is probably the most important thing, that you at least understand this. For some of you, probably old hat. But even where you've seen this informally, it's worth paying attention. Because often you're not taught this explicitly. It's just kind of thrown in as a side in a early course in math or what have you. Okay, the deal here is this. When we describe things in the world, we describe things out there, we often characterize the semantic category of the thing that we're describing. So we're measuring a length. We're measuring an area, right? We're measuring a weight of something, a pressure, a level of acceleration, or what have you. These things kind of describe the character of the thing we're recognizing. And when we say we're measuring a length or an area, we're abstracting over. We're not talking about the specific yardstick we're using, so to speak. We're not saying yet whether we're measuring the length in meters or in yards or fathoms or parsecs. We're just describing the type of thing we're measuring. It's a length. It's an area. Square meters, square feet. We're not specific. Okay. The key thing here is that those quantities which are in your model, folks, A's and B's and thetas or whatever they are, they typically have unique dimensions associated with them. They refer to something that has a dimension. And those models you build in Vensim, those different variables in it, the stocks, the flows, etc., they have dimensions. Maybe some are cost. Maybe some are cost per unit time. Abstracting over what's in Canadian dollars per week or Canadian dollars per year, what have you. It's cost per unit time. Or maybe it's people per year. Or maybe it's dollars per person. Or, mud cost per person. There are dimensions of these things. And when we're describing the world, when our models are not simply sort of arbitrary programs that manipulate numbers like a benchmark might, but they're instead describing something about the world, the quantities in it, they have a semantic meaning to them, and they describe these sort of things. Now, within a dimension, we can describe the units too. So if we're dealing with length, we might have units like foot, meters, fathoms, parsecs, etc. Furlongs. If we're dealing with seconds, we might have microseconds, weeks, centuries. These are, as it were, describe different measurement references for those things. They're yardsticks, as it were, speaking metaphorically. And these things, like the dimensions and the units, they're metadata about the numbers. Okay, our program has numbers in it, but the numbers mean something. And these things describe the meaning of those numbers. Okay, this is 4.5 what? Is it days, or is it weeks, or is it years? It matters often. It matters because it's whether the program is consistent, whether it's meaningful, in fact. So units describe our sort of yardsticks, as they were, and they relate to a particular dimension. So a given unit will be specific to a dimension. So it's units of length, or units of area, or units of time, or units of volume, or units of angle, or what have you. Now, we can convert between units. We can convert a meter to feet, something measured in meters to something in feet, and we do that routinely. We can convert something measured in microseconds to something in years. Dimensions, we don't have so we do this conversion for units by multiplying by some value. We convert inches to centimeters by multiplying by 2.54, right? We don't have a similar conversion factor between units. We don't convert a length into an area by multiplying by some unit. It's meaningless. We can't add in any way a length to an area. You can't say, well, it's 1 square foot plus 1 linear foot, and the result is 3. It doesn't make sense. Okay. And a given quantity in our model has 1 dimension, folks. It could be expressed in many units. We could describe the length of this road segment in many units, for example. And we're going to come to these special sort of quantities that are really important, because they're the natural quantities of how the world works, called dimensionless quantities. And these have units associated with them as well. Different units of angle, for example. Okay, so here's some units. So we could have a frequency as a dimension. And dimension is 1 over time, but we could have 1 per year, 1 per second, 1 per week, 1 per day. Those are all frequencies, the different units of frequency. And each of the quantities in your model, if it's a number, it should have a unit and it should have a dimension associated with it. So you should be able to think. For everything in your model, every number that's there, you should be able to say, oh, this is this unit. And if you can't, that's a sign that there may be a serious problem. For angle, we may have radians, or may measure it in degrees. This is this special quantity called dimensionless we'll come to. It has a very particular meaning, a very important meaning, a very important role. And then there's distance, where we might have dimensions of length, and we can measure it in different ways, okay? So it turns out that there's no unique dimensional system. Dimensional systems are products of our choices, and we may impose, Système International as our dimensional system for weights and measures. That's fine. We can actually choose how many dimensions we have and so on. But I'm not going to get into that, because there's some deep stuff I don't